Hi, welcome to Extreme Academy. If you like networking, you're going to like this training session. If you like Formula One and motor racing, you're going to like this. If you like both of those, you're absolutely going to love this session because we're going to look at the world of networking through the lens of a high-performance environment of Formula One. So we're going behind the scenes. We're going behind the scenes our brand new partnership with the KICK Sauber Formula One team. And in this training session, we're going to be delving into the topic of multicast. And we call this part one because we're going to do this a few times during the year. We're going to follow the team around the world. And today's part one. And future sessions, we're going to look at other technology that's involved. My name is Rowan Abbey. I'm going to introduce you to the session today. Then we've got Marco Martoni, who's going to tell us about the partnership with KICK Sauber F1 Team. Roy's then going to join us. He's going to look at the reasons why a network is so important in Formula One and what are the trends in the motor racing scene. And then the technical training topic is going to be covered by Mina Musa. And then I'll wrap up with some further training recommendations. Now, this is training, so we've got some learning objectives. So at the end of this session, you'll have a good understanding of what multicast is and its common uses. We'll delve into the legacy approach to multicast and what the limitations are. And then we'll talk about how to deploy multicast in a high-performance environment such as F1 and how you do that through Extreme Fabric. Now, there is a training session workbook, which we'll share with you. So just grab that QR code and it's got the slides and some space to draw diagrams, make notes. So you can grab that now or you can grab that after the session. Now, you could be watching this on LinkedIn or you could be watching it on YouTube or on the Extreme website. So in any of those places, please give us a like. You can share the recording with any of your colleagues. And please follow us if you're not already. Follow us on LinkedIn on Extreme Academy. So you're the first to know about future sessions and any other training that is available to you from Extreme Academy. Okay, I'm going to bring in my first guest. Let's welcome Marco. Hey, Marco, how are you?
Hey, Rowan, I'm doing well. How are you doing?
Very good. Now we've got a multinational panel today. So I'm in the UK. You're in Munich. We're broadcasting in the Asian time zone, in the Singapore time zone, because the team is in Asia right now. Just had the race in Japan. Next one's in China in a couple of weeks' time. So you're in Munich. Marco, just start us off by telling us about the relationship, the partnership we now have with KICK Sauber F1.
Yeah, absolutely. So maybe I'll take a step back for everybody. What is the team? Where's the team coming from? So I'm pretty sure everybody who has watched Formula One over the past years is familiar with the name Sauber. So Sauber Motorsport is the company behind the team. In the past years, they have been racing under the Alfa Romeo brand, and then for this year, they have gone through a massive rebrand, and they are now racing as the KICK Sauber F1 team. And that is the team that we have a partnership with, a collaboration with. And I think it's an exciting collaboration because it's a combination of two worlds where high performance is key. We have Formula One racing on the one side, and then networking technology on the other side. So what we're going to do for the team is we're providing our expertise in cloud-driven networking solutions. We're providing the latest Wi-Fi technology. And with that, we're elevating the connectivity at the racetrack to new levels in terms of speed and reliability. But our collaboration is not stopping at the racetrack. We're also working on refreshing the complete wired and wireless network infrastructure at their headquarters in Switzerland. And on top of that, we're adding our analytics platform, which provides them real-time insights into network performance, user behavior, enabling the team to optimize their operations and ultimately deliver an enhanced racing experience, which is the key for a Formula One racing team.
That's fantastic, Marco. And this is different to some of the other fantastic sports relationships we have, right? We've got stadiums with the NFL and the Super Bowl, Manchester United. This one's different because this is traveling around the world, right? So it's not a stadium. Anything you want to add to that in terms of the difference?
Yeah, I mean, it's not like if you think about stadiums, it's all about high density Wi-Fi and getting thousands and thousands of people on the network at the same time. This is a bit different because, as you said, it's not about the fans. I mean, the racetrack, there are a lot of fans at the racetrack, but that's completely, a different topic, a separate topic. This is really about the team and how they connect the racetrack,
Yeah.
the data that they generate at the racetrack back to their headquarters, how they operate at the headquarters, where they are basically building all parts of their, right, where they are manufacturing their racing car.
Yeah. There'll be some Formula One fans watching, Marco. How do people get involved? How can they follow this partnership with Extreme?
Yeah, so there are sessions like this one, and we will be working on rolling out even more content over the next months, so stay tuned for that. In addition to that, we were talking about the F1 circus going around the world this year with 24 races, which is a record year. So whenever people have the chance to be in the F1 paddock club, then we could ensure that people can visit the Sauber garage as well and get some unique insights into the operations at the racetrack. So what you can see here are some pictures from the Melbourne race 2 weeks ago, where we hosted some guests and were able to give them these insights that you wouldn't get otherwise. But then also in 2 weeks from now, on June 5th, we will be running an event, an Extreme Now event in Hinwil at the premises of Sauber Motorsport in Switzerland. So that will be an interesting event, not only because we have guest speakers from Sauber, we'll talk about the team and their operations. Of course, we'll have some keynote speakers from Extreme Networks as well. But this event will be taking place in their wind tunnel building. So that's exciting because that's something you cannot just go and visit if you want. It's a very unique environment. Doing the event there, attendees will have the chance to get some insights into the factory, basically. So save the date, June 5th. We should have the registration link live within a week or so, and we would definitely like to welcome you in Switzerland in June.
Fantastic. Now, this is a multi-year relationship, so we've got a few things happening now, but this is going to develop over time. And so if you want to get involved in something like this, then please get in touch with your Extreme representatives and see how you can get involved. As a minimum, follow the race team, follow Extreme Networks and KICK Sauber in the races. Thank you, Marco. Now, as part of this relationship, we got to send our next presenter, Roy Verboker, to the car launch. It was back in London a couple of months ago. So before we bring in Roy, let's show you how Roy got on in London at the car launch.
We are in London, and we are at a Formula One car launch for the 2024 season. This year's car, it's got a name on it, a specific name, a cool name. What we're going to be providing is installing Wi-Fi, and we're going to be installing our switching infrastructure, both at their headquarters in Hinwil in Switzerland, as well as we're going to be providing them with all the technology, Wi-Fi and switching for all the racetracks. F1 team relies on data. People seem to think that Formula One is a bunch of cool guys driving in super fast cars, doing 300 plus kilometers an hour, but that's not the case. Of course, that is part of it. But at the end of the day, these cars rely on data. How hot are the disc brakes? How many RPMs is the engine running? What's the drag on the car? What's the downforce on the car? And they need to be able to make quick decisions. What we provide is a super reliable, super fast network, very low latency, so that they can actually make those decisions, because the data is guaranteed to come in time.
Hey, Roy.
Hey, Ron. Okay. I'm doing fine. How are you?
Very good. So you've been an F1 fan, I think, all your life, right? And was that your first car launch?
Yes, it was.
What was it like?
It was amazing. It was a unique experience, and being able to mingle with some fellow Formula One enthusiasts at a car launch. I mean, like I said, it was a unique experience overall, but it was absolutely amazing. Yeah, and thank you for the company for allowing me to represent them at that event.
Yeah. Thank you, Roy. Well, so you're going to now talk for 10, 12 minutes about networks in motor racing, and why?
Yes.
Why is it important? What's the big deal with a connected car, right?
Well, yeah, I think, like I said it in the introduction video, people seem to think that Formula One is a bunch of cool young guys racing around the track at dazzling speeds. But at the end of the day, there's a reason why these speeds are increasing, right? Year over year, efficiency is increasing year over year. Lap times are improving. Every year they come back. They figured out how to shave off 1 more second of last year's record lap, right? So what a lot of people don't know, if you take a cross section of a Formula One car, you will see that specific car consists of a lot of parts, right? Of course, there's the engine, there's the body. There's tires, there's brakes, the whole 9 yards is on there. But what a lot of people don't realize is that those cars are not only filled with technology, but they're also filled with a lot of sensors. So every bit of the car is monitored by sensors, and on average, during a race, there's 250 to 300 sensors on a car, but during testing, though, that can go up to about 600 sensors a car. And all these sensors feed their information back to something that you call an ECU. It's an engine control unit. And that ECU transmits information back to the home network, if you will. And that's where all the data now, that's where the magic happens. That's where all the data analysis happens. The team data analysis or data analysts, the race engineers, they are all responsible for a specific part of the car, of the race. There's people that are responsible for the pit stop strategy. There's people responsible for the engine control. There's people responsible for the tire management. There's people actually monitoring the actual driver in the car. What a lot of people also don't know is the minute that these drivers put on their gloves, there are sensors built into the gloves, right? So it's the respiration, it's the heartbeat, it's the body temperature. Everything is being monitored, and everything is fed back into the call it the master network, if you will, and that's why low latency networking, high speed communication, and reliable and resilient communication is absolutely critical for a Formula One team. So the title of this slide, connected equals information equals driving decisions, it's 100% true. Like I mentioned a couple of times, Formula One cars are literally stuffed with sensors. Everything is being monitored, right? From tire pressure to the flow rate, the air pressure, vibrations of the car, voltage of the electrical system, temperature of the engine, even down to the body temperature of the driver. Because as I mentioned, these suits are also stuffed with sensors. The gloves of the driver have sensors, and all that data is being collected. All that data has to traverse a network, and that's why KICK Sauber, but not only KICK Sauber, every Formula One team relies on a resilient, robust, high-speed, low latency networking technology, and that's why networks are I would argue equally important, just as important as the driver is for the car. The network is basically the driver for the data. If you compare that into from an analogy perspective, car driver, there is data and there's the network. And in case of KICK Sauber, there's the data and there's extreme networks, and we make sure that we connect the dots wherever they are on the world, because those races happen in dozens of places around the world. Sometimes with 1 week in between, sometimes with 2 weeks in between. But at the end of the day, all that whole Formula One circus travels around the world, and all that data has to not only be handled locally, but also be transported back to Hinwell in Switzerland for further analysis, and that happens in real time. So that's why the network is really important to a Formula One team. Now, jumping ahead into something that is that may not be as obvious to a lot of people. There's a section of did you know? Did you know that the earbud technology wireless communication technology from that perspective, in some shape or form, finds its origin in Formula One. This goes back, multiple decades, where the pit wall was already communicating with their drivers through wireless communication, and they had built into the helmets a communication system. Tracking devices, I just mentioned it. The sensors on the car could be looked at as some kind of IoT/tracking device, but also the tracking devices that are built into the gloves and into the suit of the driver, where they monitor the oxygen levels, the temperature of the body, the heart rate, that sort of stuff, right? The patient monitoring systems, modern patient monitoring systems, find their origin in that technology. So Formula One has been a breeding ground of new technologies. And while this may not seem as obvious, I think what people will be able to relate to, and this is what you will see or hear about a lot in the news, or just in general in the in the overall sharing of information when it comes to, hey, Formula One technology is being used in everyday cars. As an example, if you look at the current steering wheel that every modern car has, you got these little buttons on there. If you can transition to the next slide, thanks, Rowan. Little steering wheel control buttons, right? To the volume up, down, gear shift paddles. That all comes directly from Formula One. Active suspension, a little bit more comfort when you drive over, a pothole or a speed bump in the road. Sensor monitoring, we have it in every car these days. If the front headlight breaks or if something is wrong with it, then you get a message in your screen in the car that says, hey, your front left headlight is broken, or your tires are running on low pressure. Also brake assist, steering control. That all that stuff finds its origin in the Formula One world. But ultimately, we just talked about connected cars. We talked about sensors. We talked about communication from and to the car. Everything needs a network to connect to basically connect the dots. If you take that one step further, there's something called connected teams in our world, in the way we think about this relationship with KICK Sauber. It's not just about the car and the data, which is arguably the most important piece, but then in the background, there's a lot of stuff happening. We're talking hundreds of people walking around the racetrack or in the factory. Everybody walks around with wearables, with phones, with tablets, with laptops. There's all kinds of stations that people use, CCTV. There is a tremendous need for network connectivity. And then if you look at it from a race perspective, there is the garage, there's the pit wall, there is the hospitality area where they invite their guests to. Then there is the factory, and then there is also offices. I mean, there's a lot of things happening in the background with every Formula One race. And then if you look at it, they monitor everything from the driver to the car. There is TV broadcasting signals. There is CCTV camera systems. There's Wi-Fi. There's guests that are on the Wi-Fi. There's a lot of stuff happening at the same time, and that's what Extreme provides KICK Sauber with: a reliable Wi-Fi network, a robust, resilient switching network, and we do that across the world wherever they are. So from that perspective, Rowan, that was a little bit of a leading intro into the next section. But
great story, Roy. Thank you. Just before we let you go, there's one thing on here that some people may not be familiar with: telemetry and Atlas. What's Atlas?
So Atlas stands for a very expensive explanation here: Advanced Telemetry Linked Acquisition System. The bottom line is that is basically the data analysis piece that I just talked about. So all these sensors collect information. They are connected to a part of the car, and there's vibration sensors, there is temperature sensors, there's pressure sensors, there's speed sensors. I mean, there's all kinds of stuff. All that data is fed into this system called Atlas. And Atlas is the official provider. So every Formula One team leverages Atlas, and that's why it's so important. And I think that's also why it's so interesting to see the reliance on that data, the criticality of that data, and that data coming from actually moving from point A to point B in real time with as little interruption as possible. Or at all, I would actually argue. Very low latency, milliseconds we're talking about, maybe even microseconds. That's why the network is so crucially important. That's why the next section, talking about the multicasting piece, is going to be an interesting one. But it just shows you how serious these teams are taking data, and the effort they're willing to put in to make sure that the data that they collect is number one, reliable, and number two, is relevant enough for them to be jumping on board with Extreme Networks and allowing us the opportunity to show what we do in the commercial enterprise healthcare education space and taking that into the world of Formula One. That for us, number one, is really, really exciting. But also for them, it's you never know what you're going to get until you actually try it. But in this case, we have already proven our value. We've already proven our worth. And I think, like I said, the next section for with Mina is going to be an interesting one for especially for the technical people. They're going to see the relevance of multicast, but also the challenges of multicast and how we solve for that.
Yeah, fascinating, Roy. I think people are watching this. They might be working in a hospital environment, an airport, a university campus. There's commonality, right, between these use cases, and it's data. It's what can you do with the data? What real time applications are there, and how does the network support the outcomes of the business? So we can keep drawing those analogies. It's not just about Formula One, right? Thank you, Roy. Well, you stick around because if you want to ask Roy a question, or if you've got a comment, just pop it in the comment section below. If you're watching on LinkedIn or YouTube, and Roy, you can answer some of those if you want to hang around, see if you've got any questions. So thank you for now. I'll just do a quick recap on the agenda. So we've heard from Marco on the relationship and the partnership. We just heard from Roy about how we're powering an F1 race team. And next, coming up, we've got Mina Musa on Multicast. Before we bring Muna in, I just want to remind you that you can download the slides. We've created a training session workbook. You can download that from this QR code on screen, and then you can save that. And each time we do one of these sessions, we'll do a similar training session workbook, so you can build up your knowledge around this exciting topic. Let's say hi to Mina. How are you?
Hello, Rohan. I'm good. How are you?
I'm very good. Now you're in Melbourne, and I see you're fully branded. Well done.
Yes. I got it as a giveaway from the KICK team, answering one of their questions in the hospitality unit. So yeah.
Well done. Now you got to go to the race in Melbourne. How was it? What were you doing?
Man, that was an absolute great experience. It's my first time to be that close to an F1 team behind the scene. So having our customers and our partners on that close distance, going through what's happening in the pit garage and seeing from a close distance the pit wall, and how the team in the pit stop basically starting their journey all the way from warming up to have a lot of trials about changing tires, going through a lot of every single station inside the pit garage itself, seeing the radio communication system, seeing the tires, which labeled, every single tire labeled with a sensor measuring the temperature of the tires. And honestly, was such an amazing experience. And a lot of our partners, a lot of our customers loved it. So I'm glad that this is going to be for 5 years. So hopefully next year, when it's come to the Melbourne again, I'll have the opportunity, myself and the team here, alongside the customer and partner, to see the same experience again.
Fantastic. Well, it looks like we made you into an F1 fan, Mina.
Absolutely.
Long life ahead of you as an F1 fan. Okay, so we've heard from Marco about the partnership, Roy about the reason why a network's so important. So now let's get behind the scenes. Let's get into the technical details of one area of that partnership, which is Multicast. So you're going to take us through this training for about 20 minutes now. But kick us off, with just a definition.
Yeah. I'm just going to cover the definition of multicast, but most importantly, what is the purpose of having multicast in today's network? Multicast being around for a long time, and there is a well-known application using multicast like CCTV, video surveillance, and also like IPTV in hospitalities side of things. But there is other applications running multicast these days. Some IoT sensors require multicast. Some other application like anyone doing things in stock market and trading could require the multicast. Whether you are in hospitality or any other verticals, healthcare, you would need to have multicast. CCTV by itself as an application required multicast, showing that every single organization, every single enterprise network required a multicast to be part of the network. And there's a different way of communication, as we can see on the screen. Multicast is one of them, but for the technical audience, you're definitely aware about unicast communication, which is one-to-one communication. You may be aware of broadcast communication. A lot of us basically coming from the background hate to have a lot of broadcast happening in the network, because that could lead to a loop in the infrastructure. But multicast is basically ability to not send a traffic to every single node in the network, but to a specific nodes in the network. So you can call it one-to-many or even many-to-many distributions in case of having, for example, multiple workstations watching multiple cameras. That's basically the definition of multicast. But the main reason we needed multicast in our infrastructure is to make sure that we drive efficiency in the network. So what I'm going to do here basically is I'm going to take you guys through a journey of how we doing networking for a long time, how we are provisioning services on the legacy way. I'm going to call it legacy because since I came to the networking field, this is how I do it day to day. And then we're going to have the shift to show you how we can drive you using simplicity and security and flexibility, building the same capability, but in a much easier way. So looking here in front of us, this is the same standard architecture that you would find it in any enterprise networks. You're going to have basically edge devices, which is connected to the access layer, where your switch is connected to basically a distribution, and distribution connected to the campus core. This is a typical 3-layer architecture: core, distribution, access. And access, we have our edge devices. I put a camera because this is going to be basically the main theme for the day of focusing on the multicast. And we could have a server here hosted in the data center connected to a top of rack, connected to a data center core, and the data center need to communicate back to the campus. So we need to have this communication. This is basically how the network being built in the majority of our infrastructure today. But if I want to have this camera to communicate with this DVR, I will start with a traditional layer 2 provisioning for the services. We're gonna need to configure a VLAN in every single hop in the network. So if you look here, basically, you need to configure the VLAN in every single hop in the network. Let me also use a laser point. So you're gonna configure the VLAN on this switch, and on that switch, and on this switch, and on that switch, and on this switch. Every single hop in the network required to have the VLAN in order to provision a path between the camera and the server. Basically, that could be an easy in a layer 2, but that's not having any level of redundancy or if something happened to the network. So what we need to do, we need to ensure that the VLANs are also available on the other sides of the network. And once you start provisioning a redundant path with a VLAN configured on it, we all know what will happen. We're going to have the most challenging, I would say, the most challenging issue we have in the network these days, which is a network loop going to be introduced. So you would need to worry about spanning tree to block certain routes and make sure that you have that route disabled and the forwarding happening on that specific route. This is how we configure network for edges. And if this is network need to be scalable enough, you would introduce routing protocols. You would introduce a multicast routing protocol like BIM to configure and make this network as a scalable. So what I'm trying to demonstrate here is the way we configure network for years is very complex. It's hop by hop provisioning. I need to touch every single hop in the network to provision a path between the source and the destination. If I want to move or to add or to do any change in the network, I need to touch every single hop. And guess what? We are all human. We are all engineers. When we start troubleshooting things, we love to get our console connected to the switch and start doing the troubleshooting. And that may introduce other issues. It's very complex to troubleshoot such network in these days, given the number of connected devices, given the amount of data traversed across the infrastructure today. Troubleshooting is absolutely an important point that you need to care of for your day-to-day operation. So, as I said, this is a traditional layer 2 infrastructure, only IGMP running here because it's layer 2. If I want to scale this and make it more scalable, I need to introduce a multicast routing protocol. And the most well-known multicast routing protocol we know these days is PIM, Protocol Independent Multicast. Everyone call it protocol independent. I always call it protocol dependent because PIM cannot run by itself. So let's imagine how BIM is working. And when you understand how BIM is working, you would understand how simple the network can be done with Extreme Fabric Connect. So I have here a receiver, and this receiver could be a workstation. Try to receive a multicast stream from a camera. Consider this multicast sender as a camera. Or you could consider it even in an IPTV environment. This receiver could be IPTV set-top box. Try to browse to a certain channel which holding a multicast address. So the receiver going to send an IGMP request to the switch connected to. But as we know, there's two different types of PIM, and it's very important to decide which mode of PIM is well fit for your use case. So let's take BIM dense mode as an example in the beginning. What's going to happen is there is an IGMB send request going to go to this connected switch, as I said here, but the sender gonna basically flood the multicast stream to every single router in the network. So in a dense mode, every single link, first of all, need to be configured with IB dense mode enabled, but most importantly, the sender will not direct the traffic between the source to the destination, and instead it will use a technique called flood and prune. So it's going to flood the traffic across every single BIM router in the topology. Guess what? You remember when I said we made multicast for efficiency? This is not an efficient way. This is not a scalable way to basically manage your infrastructure. So we discovered that BIM dense mode, it's not scalable. It's absolutely complex because you need to touch every single router in topology and every single link in the topology to make sure that BIM dense mode is enabled. And most importantly, the BIM always relying on the IGP protocol running underneath, relying on the unicast routing underneath, whether you are running OSPF, RIP, IBGP, or ISIS, regardless the protocol that you're running underneath, BIM is always relying on it to do something very important called reverse pass forwarding check. And reverse pass forwarding check is needed to ensure that you have a loop-free multicast routing in your infrastructure. Trust me, one of the most complex troubleshooting case for any network engineer is always when someone's saying, oh, I cannot see the camera stream, or the camera is freezing. At that time, you do not know where is the issue and in which layer in the network. So it's a very, very complex way. But let's forget about BIM dense mode and jump into the BIM sparse mode. BIM sparse mode meant to be more scalable than BIM dense mode. But again, there is a lot of complexity in the process itself. The first thing you need to discover your BIM neighbors. So in all cases, you need to discover the BIM neighbors, but every 30 seconds, there's a hello packets being shared between the two routers, any two routers here. Every 30 seconds, this is a hello timer. We know the concept of hello and dead interval. This is basically hello and dead timer exists in a lot of routing protocol as well. But before removing a neighborship, you need to wait for the dead timer to be expired. So we're talking about 30, 90 seconds to consider that this neighborship for the BIM protocol is down. There's a lot of time. It's a lot of time. There's a lot of timer you can add it and a lot of enhancement to reduce this timer, but trust me, it's still gonna be multiple seconds before the network to reconverge. But coming back to the BIM sparse mode, it's not gonna do a flood and prune, but it's gonna do something very important. It's gonna elect certain rendezvous point. So every single router in the topology need to discover the rendezvous point, need to be aware where is the rendezvous point. Why? Because the rendezvous point acting as a mediator here. The rendezvous point is going to arrange how the receiver can reach to the source sender. The rendezvous point is going to be aware of every source and group in the infrastructure across all the senders. And when the receiver wants to receive certain multicast stream, basically, the sender going to send the source and group to the rendezvous point. The receiver going to communicate with the rendezvous point to receive the multicast stream. So you need to rely on the rendezvous point. You need to decide which router in your topology is going to act as a rendezvous point. You need to have a backup rendezvous point in your topology. You could do it dynamically. You could do it statically and configure every single router in the topology, defining the rendezvous point. This is a lot of effort need to be put into the time of deployment to decide first which mode you're going to go with to route multicast, sparse mode or dense mode. Dense mode is in most cases is not going to be your source of choice. Maybe you're going to rely on sparse mode, but again, the complexity around choosing where is the rendezvous point, the complexity around relying again on the IGP protocols underneath to drive you for a reverse pass forwarding check to ensure loop-free routing, a lot of complexity, and basically there is a lot of dependency here as well. This is network. Some people call it a scalable multicast with a sparse mode, but with today's and how the network been running in these days and how many cameras you could have in the infrastructure alongside other multicast applications, this network is no longer scalable. There is no longer reliable. And remember when I discussed about the hello and dead intervals stuff and reconvergence time for the multicast, absolutely required a lot of time. All right, so how we could solve these issues? How Extreme Fabric can solve these issues? Because Extreme is not relying on the traditional way of building networks. Extreme trying to simplify the way of building the network today. How we build the network today, we're going away from all these stacks of protocols to build the infrastructure and replace it with one single open standard protocol called IEEE 802.1AQ. Single protocol to drive the unicast routing, single protocol to drive the multicast routing. It's faster to deploy because they are not relying on that multiple stack of deployment. It's very easy to troubleshoot because you are troubleshooting one single protocol, and way faster for resiliency because you don't need to wait for a spanning tree to reconverge, then wait for OSPF to reconverge, for BIM to reconverge. That reconvergence time for every single protocol in the network is no longer needed with Extreme Fabric Connect. Fabric Connect gonna drive you for simplicity, automation, and security. Let's start first thing with the simplicity of building the fabric. Basically, get your switches out of the box, connect the switches together on any port with any fashion or form, whether you connect them copper or fiber, whether you connect port 1 or port 24 or 48, it doesn't matter. It's true plug and play. Once you connect the switch become part of the fabric. So you have 4 switches or 400 switches. Trust me, all what you need to do, take your switches out of the box, wire them together in any fashion or form, and that will configure for you one single logical fabric. Fabric is self-forming, self-healing, and also self-provisioning. If you notice here, I put the topology intentionally to be looking like that way. There is no network like this, but this is to drive you using the implicit automation and the controller-less fabric. There is no dependency here on a controller to drive the fabric provisioning for you, but completely topology independent. It can scale to any number of nodes, and also it can scale on the services as well when we start provisioning services on top of it. Remember what I said, and you can hold me accountable for that. If you connect any number of switches together and you connect your console to any of those switches and show fabric nodes, you will find all the fabric devices connected together in one single fabric. Through plug and play, implicit automation, controller-less fabric, topology independent to give you the flexibility to connect your network together. You remember when Roy discussing about connected cars and connected networks? F1 KICK Sauber Team has multiple locations, and there is a network in every single locations, but we need to drive one single unified network for them, and we call it one single secure automated network. Whether you connected in the factory or the bit wall, whether you connected on the hospitality unit or the bit garage, you need to be connected in a secure automated way. And all these data and all these analytics required in the network today needs to be basically traversed in less than milliseconds to be analyzed, regardless where it's need to traverse to. This is going to lead me to the resiliency of the fabric, called A2.1 AQ. And basically, you could have multiple redundant paths, and you could have the video surveillance and the video surveillance server, but the traffic gonna always take the shortest path. If there is a multiple equal cost path, the traffic gonna load balance between them. But most importantly, if there is any disruption happening in the network, there is an instantaneous recovery. We're talking about 200 milliseconds for the recovery for fabrics and the services on top of the fabric as well. You do not need to wait for every single protocol, as I said, to reconverge. Resiliency is a key, and connected cars, connected networks, and big data generated on this network require the network to be an absolutely fully resilient. So how we do it today, all right, with fabric. You remember when I told you that you need to touch every single hop in the network to provision the path between the source and the destination in a layer 2? This is no longer the case, because once you connect all these switches together in any fashion or form, they're going to form one single unified fabric. So all what you need to do is to provision networks only at the edge of the network. So you would definitely need to configure a VLAN on that specific switch, and you would need to configure a VLAN on the other switch, but you need to tie this VLAN to something called virtual service network. Every service on the fabric going to have a specific ID, and you can have between 1 to 16 million plus service IDs. So all what you need to do is only configure the service at the edge of the network and tie this VLAN to specific service ID. So the CCTV zone service here gonna have ID 100. If you have other services, you're gonna tie those other services to a different ID to ensure a complete segmented and segregated network. Remember, simplicity should not take anything from being a complete secure network. And this is the beauty of the fabric. Simplicity with the security ingrained in the protocol itself. And you can easily expand this across multiple locations. So you have multiple cameras there, it's going to be tied to that specific service ID. Trust me, if you access any of the switches in the middle and type our beautiful command show VLAN, you will not find that VLAN 100 exist in any switch. Why? Because Fabric made the network as one single logical switch, and service provisioning on top of it became completely edge automated services than hop by hop. This is in a layer 2 environment. How it happened in a layer 3. As I said, number one, goodbye BIM, goodbye DVMRP, goodbye that types of complexity. We're going to simplify the way, because we connected this network, and this network being seen on one single logical switch, we're gonna drive a true efficiency using Extreme Fabric Connect. You remember when I talk about flood and prune or RB election and having a low and dead interval and all this stuff, this is no longer the case. If I have a receiver want to receive a single multicast stream in the network, only that specific receiver gonna send an IGMP request and gonna receive the stream at the edge. There is no flood to everywhere, and there is no worried about to communicate with an RP or something like that. It's absolutely the receiver gonna request the IGMP, and that specific stream gonna forward it only to those receiver who requested. So let's think about another case. Another receiver's gonna request and gonna be tied that multicast stream to that specific service ID. You see here, I have a 16,000,001 service ID. Basically, above 16 million being reserved to the multicast services inside the fabric. Same thing for another one. Only the IGMB and only the stream gonna be reached to the receiver who requested that specific stream, and goodbye to all complexity the BIM introduced, and goodbye to the long time for reconversions, because the resiliency in the fabric is 200 milliseconds, regardless you are running unicast or you're running multicast, because there is no any dependency here, as I said before. Flexibility comes from the network topology. Imagine you need to stretch your network anywhere. Trust me, today we having our own Bob. I'm not sure if you are in Australia, you definitely met Bob before. It's such a nice network in a box, and this network running a CCTV with a multicast. I can see other cameras with every single Bob with other people across the entire company. So I can see the cameras in US, and I can see the cameras in Singapore. How? Because fabric can have the elasticity to stretch the fabric across any other media. You can basically take it over the secure internet using our SD-WAN technology, but bringing everything together with the flexibility and simplicity and scalability to tens of thousands of streams, and having that in a true multi-tenant infrastructure is absolutely a key. So I'm very excited basically to be with you today and cover a bit on a glimpse of what multicast. I'm very excited because I have deployed the legacy way, and I have deployed a big fabric multicast network before, and I truly believe on this technology, how simplified that all being points. So that's basically what I wanted to cover, Rohan, from multicast point of view. And I'm open if you have any questions.
That's amazing, Mina. That is, so you're definitely taking us behind the scenes on the technology used in high performance areas, such as the KICK Sauber Formula One partnership. So thank you for that. Now, if you've got any questions for Mina, then just put them in the chat or the comment section. We'll get back to you either live while we're broadcasting, or we'll reply offline depending on when you're watching this. So thanks again, Mina. Just hang out with me for a moment. I'm just gonna cover a couple of things before we wrap this up. If you've enjoyed this, if you're interested in learning more, we've got some more training for you. We've got a professional certification track around extreme fabric, as well as other extreme technologies have a similar track. In this one, it starts with a free of charge welcome series where we introduce you to extreme fabric. That's available on our YouTube channel right now, so you can go and check that out. It's free of charge, and that leads in to the professional certification curriculum, which covers installation and configuration, advanced configuration, the management of the fabric, and troubleshooting as well. So if you want to follow that learning journey, then you can do that. Check it out. Check for more information by going to extremenetworks.com/support/training. I'll just recap. So in this training, we looked at multicast, we looked at the legacy approach to multicast and its limitations, and then we also looked at how can you do that a different way? How could you do that with extreme fabric for demanding environments? Now, all the slides we've used today are in this training session workbook, so you can download those just by going to that link, and then we'll do that again. We'll do that again in each of these sessions, so you can build up this workbook over time. So we're coming to the end now. I'll just bring Marco back up on screen so we can thank Mina, thank Marco. I think Roy's had to rush off to another meeting, so we can catch up with Roy online if you've got any questions for Roy. Marco, I'm going to finish with a little bit of a trivia quiz for you. Test your F1 knowledge. Where's the next race? Where's the next race, Marco?
The next race is actually in Shanghai, China, and it's the first race in China after, I think, a 5-year pause due to the pandemic. So everyone is excited to go back to that track.
Yeah, absolutely. And it's Zhou Guangyu's home race. So
Exactly,
Sauber, KICK Sauber F1 driver. It's his home race. A lot of pressure, a lot of focus, and we wish him well. So we thought we'd end this session. You've met our drivers. We thought we'd end this session by showing you a little video so you can get to know the drivers of KICK Sauber F1. So check this out for about 90 seconds, and then we'll wish you well, and we'll see you on the next training.
Ooh la la. Coffee.
Formula One is back, live on Bolt TV.
All this goosebumps, all this nervous tension.
Okay, Joe, box.
I want to be a bit more aggressive, a bit more attacking.
Okay, Marty, you missed PRS by just 1/10 of Salzburg.
Music, if I had to listen while racing, like soundtrack of nature sounds. I want to be in the podium. That's my mindset.
And we just purely focus on what we have to do.
One way or the other, I want to be there.
Okay, target 4 to 5 second gap. Joe, push when you're ready. Look, push. And your gap ahead to Joe currently 2 seconds. And 3 seconds to the crowd behind.
That's what I've prepared pretty much all my life, you know?
Let's go, guys! Come on!
Good job.